Hello, everyone, and welcome back to the Genomics Bootcamp. It is good to be back also for me. This time we will be speaking about a change of the so-called 705 file format to PLINK. Well, this is a very specific file format, so maybe this video will be useful for 3.5 people, but still, I think it is useful to know. First of all, what is a 705 file format? So it is a very specific and very effective file format where you basically have one animal or one individual per line with the genotype coding of the individuals. So there are various possibilities. What could such a file include? So this is then described in the interbul.org web page, and here is also then the various columns it might have, but the most important one, actually there are just a few. So the ID of the individual or the animal, so this is something that is usually there or must be there. Also, this is a very specific file format where you can have various chip types in one file. So basically it starts at a certain point and just goes until the chip is over. So you can have various chip types in the same file, meaning that you can have a bunch of animals with the 50K, other bunch with the 20K, yet another bunch with the HD and so on, and all of them in the very same file. So that's why you have a column that has a number of SNPs in the SNP chip that is being reported. So this column is basically designates how many, well, just genotypes or SNP genotypes are in that row. And then it is followed by the one column or basically one character per genotype. And that is 0 for the one homozygous, 1 for the heterozygous, 2 for the other homozygous, and 5 for the missing. So that is then the genotype coding that is being used. So other than that, there could be various other columns that are described here, and these might or might not occur. Now, there is also a important thing is that for each of the SNP chips that is being reported, you should have a separate map file that refers to that line for which this SNP chip is being reported. So what I did is I prepared a very small example file that I will also share with you, and you can find the link to this file in the description of this video down below. And so this is, well, a short version of such a 705 file. Well, you might notice that the extension is not a .txt, but it's still a text file. So what we have here is, well, just a column of designating usually the breed name, but well, I have this one as an anonymous file. So that is a column that we will use as an FID column for our PLINK file when we change it. The individual ID is, well, this is also in this case, well, anonymized, but this is the one line per individual. Now this line is, or this column is the column for the number of SNPs on the chip. And again, well, I don't want to get into too much trouble of sharing, well, real data. So I just made a smaller one. So, but this is what I meant. So that basically in this case, I have a 3 basically made up chips, one with 10 SNPs, other with 15, and yet another one with 20 SNPs. And you see that all of these are basically in the same file, and they are followed by as many characters as many well, SNPs are indicated. So with a 10, if there is a 10 SNPs on a chip, then it's 10 characters, 15 is 15 characters, 20 for 20. The same way, if this would be a 54,000 here, then it would be followed by the 54,000 characters in that line. Also, what I told you, so for the each SNP chip that is indicated in the 705 file, there are separate map files that are provided, and these are then provided by the same source, whoever provides the 705 file. And now we are here to the core of the video, that is changing of this 705 file format to PLINK. Well, this file format initially is very effective one or efficient one space-wise, but it cannot be loaded in PLINK. So we can change that, of course, and it is not that difficult. So we will use tidyverse and R and RStudio as usual. We will load this file with the read table command, and well, we will select one specific chip type, because as you know, in the PLINK files, there is one specific chip per pet file. So it has one pet file, it's one with one map file. So basically it needs to be just one type. And because this 705 file format has multiple, so we have to select the one that we want. So for example, we want the SNPs or the animals that are genotyped for 20 SNPs in this very small example. So we use the filter option for that particular column. In PLINK, we add the other columns that are needed, and that is the sire, the dam, the sex, and the phenotype, which is, well, we don't know, but still we create these columns in order to avoid any problems later on. And then we select basically the first column, which we'll be using as the FID, the IID still from the 705 file, the sire, dam, sex, and phenotype that we just created, and the X4 that is right now the series of characters with the, well, with the genotypes. And so this is how it looks like. So you see it's almost okay for a pet file, but there is one problem, that this part is, or the last column or the last part where the genotypes are, that is still in the genotype file format and not the allele format. And it doesn't have any spaces in between them, which is also, well, necessary. So we will do just that in the following part. So we will use somewhat of a brute force approach, and we will just do a very simple thing and replacing well, the zeros with AA, the ones, well, because this is the heterozygote, so this ABs, the 2s with the BBs, and the 5 with the dash dash for the missing genotypes or the missing SNPs. Now you see that we also implement spacing in between, so in a, well, rather clever way. So we will introduce one space between the alleles and also one space after the allele, because just in order to introduce the spaces also in between the SNP genotypes. In this case, we will produce a pet file with the AB format, so which we then write out with the write delim R function, and yeah, and basically that is it for the pet file. Now you're probably wondering why I have also this other part here, which seems to be, well, unnecessarily complicated. Now, this is for the case if you really need to recode the pet file, not into the AB format, but into a numerical format, which is actually, now thinking about it, you can just recode to AB and do a recoding in PLINK with, for example, dash dash recode 1, 2 or similar, but you can also do it directly from R. So here there is a bit of a trick that you need to change first to well, anything else than numbers, because the thing is that if you would change 0 to 1, 1, then in the next change or the next line, you would basically replace some of the ones or the character ones that you have created previously, which would lead to a huge mess in your data file that you just created. and it would not just not work with PLINK. Now, that's why you first change to, well, I change it to ABCD, and then the changing the ABCD into the numerical allele coding the same way as before, introducing also the spaces in between the alleles and also after the allele. And if you open this file on your computer, then you see that these are exactly the 3 animals that are genotyped for these 20 SNPs. And this is how they look like, or the genotypes look like in the AB format. The next step, what you need to do is also create a map file, well, with the very same approach, basically reading the map file you got from the data provider and change it to the usual PLINK map file format, that is the chromosome, SNP name, Morgan, and the base pair position. Well, depending on the format of the map file you got, you need to do these changes. Well, in my case, the map file was created okay already. So basically all I need to do is basically just to change the name, and that is to match with the pet file name. Well, I do this in these few lines, and then basically we are ready, and we change the 705 file format to PLINK. Of course, it's always good to test if you've done everything correctly, and the test in this case is run PLINK with, well, basically anything or any command. In my case, I just make a binary pet file, and yeah, just to see if it runs without problems. If you used, and if you kind of assign the missing ones as a dash, then do not forget to use the -- missing genotype dash command here, or option, just to indicate this to PLINK. And if you run it, so then you should get no errors. And well, if you do not get no errors, at least you know that the transformation was correct. Also, always check if the number of SNPs and the individuals are as expected. But in my case, we have 20 variants and 3 cattle, as well as we expect it to happen. So all is good. So I hope you find this video useful. If yes, leave a like, leave a comment, and then I will be back with another video soon. For now, thank you for your time and have a really nice day.